Good afternoon, everyone. There's actually two challenges in doing a presentation in the afternoon. The first is that it's right after lunch, so I hope no one dozes off here. And then the second is that we've listened to a number of great presentations this morning, and these are tough acts to follow, so it makes challenge number one even more challenging, so hang in there, all right? So once again, thanks Keith for the introduction. I'm Cesar Chan. I'm Director of Product Stewardship for US Gypsum, and I'm really excited to once again have the opportunity to honor Ken Hover and celebrate the career of this great professional teacher and friend. Now at this convention, you probably noticed there's been a number of events that are planned for Ken, and we're honoring his time and contributions to ACI and to the industry. But the fun and celebrations actually started last summer in Ithaca, New York. So we had former students spanning 4 decades come to Cornell and gather for an afternoon of sharing and reminiscing of our times as students of Ken Hover. This continued with a very cozy evening at Ken and Deb's place, followed by a very pleasant Sunday afternoon at one of Ithaca's local state parks. So there were lots of memories shared on this beautiful weekend in Ithaca. There were lots of good stories and laughter among the participants. But being the scientists that we are, we couldn't help ourselves from looking at time-dependent effects. Right? So, and what we find is that in the course of 16 years, humans really don't change a whole lot, except for small changes in hair color and style and choice of eyeglasses and whether to wear them or not. But I remember Ken used to talk about this phenomena that happens to humans with age, similar to Poisson's ratio. You know, it goes one way and it comes out the other way. And fortunately, we didn't quite see that here. So, you know, so that's that. So for those whom I haven't met yet, here's a brief bio about myself. I grew up in Canada. I did my undergraduate and master's degree at the University of British Columbia. Then I worked for several years in a consulting company, AMEC. And during this time, my heart started pointing me towards a PhD. And my mentor then, Dr. Rusty Morgan, he said that if you wanted good education and a good teacher, you have to go to Cornell and find Ken Hover. And that's exactly what my journey was. So after 4 years at Cornell, I joined the Innovation Center at USG in the Chicago area, taken on different roles over the years in product development, running an R&D in Asia Pacific, and now on this product stewardship role. But it was really those 4 years at Cornell where I had my greatest interaction with Ken, and it's an experience that I'll always remember. So my research at Cornell focused on the durability, specifically on the freestall durability of segmental retaining wall units. Now these are masonry type of units that are used for retaining walls, like the ones that you see there. And you commonly see these in along the highways, in like golf courses, in shopping areas. And they have been very popular across the country. You see them all over the place, but there's also been documented cases of damage in the field. And so we undertook this study in collaboration with the University of Texas at Austin, Dr. Kevin Folliard. And one of our initial tasks was to try to replicate different forms of damage that we're seeing in the field. So we looked at salt blooms, sulfate attack, wetting and drying, freezing and thawing. And one of the, what was unique about these concretes is their internal network of irregular and interconnected voids. And for some reason, Ken called these little guys. I don't know what was it about the boys, but you call them little guys. So I always remember that. But then our research then led into in-depth studies on freestall performance, specifically variations in freestall performance when testing according to a specific ASTM standard. And I never imagined that we could be looking at freezers in this manner, and Tim Bond remembers this very well. But people thought we were crazy when we loaded freezers with thermocouples. I mean, dozens and dozens of thermocouples in the freezers. You had to dodge them. You had to make sure they didn't move out of place. You had to make sure they were all calibrated. And people are wondering, like, why are you putting so many thermocouples in the freezer? All you need is one. You put it in the middle and, should be representative. But we said, no. You have to map out the variations. And this turned out to be vital because understanding these variations help us understand how they impact sample durability. So after about 3 years of trying to break porous concrete in different ways and fighting with these freezers, we wrapped up our work through several major accomplishments. The first, according to Ken, we became professional freezerologists. So even today, I'm still trying to decipher what that is, but has something to do with freezers. Second, through these freeze-thaw studies, together with studies on the material properties, sampling methods, analysis methods, we were able to do a systematic critique of the ASTM method and provide recommendations to tighten it up. And then in the process of doing that, we also learned quite a bit on these high porosity concretes. So that was my research at Cornell. Now, of course, breaking porous concrete and fighting with freezers were not the only things that Ken had me do. He wanted me to go out and share this with others. So in this regard, I have 3 memorable experiences that I can share here. The first is, no surprise, papers. So we kept very busy writing up our work, journal articles, conference proceedings, industry reports. And I still remember the suspense of getting those red marked drafts back from Ken after every revision. But over time, I learned that there was a method to it and things got better. Yeah. Second was my first ACI, spring 2005 in New York. And Ken gave me the opportunity to attend this ACI, and I really appreciate it. How he took the time to connect me to his network and to help me navigate through the convention, especially being my first one. But there's one very specific instance from that convention that I remember today, and that happened at the concrete mixer. So Ken, along with 2 of my former advisors, they converged on the table where I was seated, and they just started happily and heartily talking to one another. And for a moment, I couldn't believe it. 3 generations of advisors, Nemi Banthia, Rusty Morian, Ken Hover, all there talking together like there was no passage of time or anything like that. And it felt like a time warp. But the strangest thing was that in the background, they were playing Phantom of the Opera on stage, and it just added to that surreal feeling then. So still remember that well. And then, Ken was very generous, and he wanted me to go out and meet more people, so he sent me to different meetings and conventions, like the ones at NIST, conferences, and a couple of conventions for the National Concrete Masonry Association. The first one, I don't remember too well, but the second one became known as the So What Conference. And the reason is because we had very enthusiastically talked about our work and all the good research that we were doing on SRWs. At the end of the talk, one member of the audience stood up and said, "Hey, your work is really good and interesting, but so what?" And there was a moment of silence. We had to spend the next 10, 15 minutes trying to explain and doing damage control. But this was a good lesson about knowing your audience. So with Ken, we wrote a lot of papers. I went to my first ACI, and we presented at the So What conference. Now, on to Ken himself, and I'm using the same slide here that I used in Ithaca last summer. Over the years, I've participated in different leadership courses. And one of my favorite ones is this one called The Only Leaders Worth Following by Tim Spiker, and I highly recommend that. And here it talks about good leaders being like strong trees, like robust trees. You have to be inwardly sound with strong roots, and you have to be others focused with beautiful leaves and branches extending out. And for others focused, there's 5 qualities that are talked about in there. And each time we were asked to think about these 5 qualities and of past leaders that exemplify those 5, I would always remember of Ken. So I'm going to share with you what these 5 qualities are and how they apply to Ken. The first is attentive. Ken spent a lot of time with me during those 4 years in my PhD, either in project meetings, for lunch, casual conversations, Friday afternoon conversations, But each of those discussions could last for hours, and he would just drop everything that he was doing and give full attention to our conversations. This is how we got to know each other well and to brainstorm many different ideas. Second is curious. We all agree that Ken's curiosity has led him to different research topics over the decades, but he also has a vested curiosity for people, for their background, for their interests, for their well-being, and that's what makes him so personable. Then we have empathic. So being a foreign student in the US, of course we had our own challenges, and Ken was understanding of those, and he was very accommodating and always ready to jump out and help. And we did a lot of the planning for my research around these other considerations, so that was really appreciated. Humble. I'm always amazed how well Ken connects with every person, whether they're students, teachers, professionals, people in the field, within the industry, outside the industry. It doesn't matter. He has a way of connecting with people. And his love for his family and service to church are also examples of this character. And last but not least is agapon. And this is a new word that I had learned, which means a total and unconditional care for others. And this is what I experienced with Ken. So he cared that I had good quality research, and he also cared about my personal growth and career. And he blended the professional and personal aspects so seamlessly that my years at Cornell were not just about breaking porous concrete and fighting with freezers, but it was about becoming a better person. And this came at a very important time because I was transitioning as a student, a grad student, getting married in a different country. So I had no better person to look up to than Ken during those years. So that's why every time I hear of the word agapon, which is an uncommon word, but I do think of Ken whenever that comes up. So for all of these, I want to once again say thank you, muchas gracias, for all that you've done, and turn those 4 years at Cornell into a light of inspiration for my career. Thank you very much.